Hi guys, so this is the third of the 5 problems in our mini series for systems of equations in 3 variables. So we're gonna go ahead solve the system, you guessed it, by elimination. So gentle reminder, our first step is to put all the equations are in standard form, x, y, z equals constant. Cool. And then we're gonna pair up equations to eliminate the same variable. The question is, which one should we eliminate? There's no right or wrong answer. There's really a personal choice. But in this case, with your permission, we're gonna go ahead eliminate y. And the reason being is because see how we have a negative y and a positive y? So if we were to add these equations, they're already gonna cancel out. So this problem is screaming, hey, eliminate y. Okay. So we're going to go ahead make 2 pairs of equations and eliminate that y. So the first 2 equations that I'm going to pair are the ones that help me make that call. So we're going to pair up equations 1 and 3. So we're going to write pair 1 and 3. So equation 1 is 2x minus y plus 3z equals 7. And equation 3 is 3x plus y plus 2z equals 2. Fantastic. So let's go ahead pair. We already used 1 and 3, so for sure we have to use 2 with something else. Which one? I'm going to pair it with equation 1. Why? Because if I can have a positive something and a negative something, that will avoid me having to multiply by a negative. So I'm going to pair it with 1. So I'm going to pair 2 and 1, or I'm going to say pair 1 and 2. So pair 1 and 2. So equation 1 reads 2x minus y plus 3z equals 7, and equation 2 reads x plus 2y minus z equals negative 3. Okay, fantastic. So let's go ahead and remind ourselves, what variable are we trying to eliminate? We are trying to eliminate the y, so let's do this. For the first pair, the coefficients are opposite, so we have green light to add. So when we do that, will leave us with 5x plus 5z equals, where am I, 9? Yeah, okay. For the second pair, the coefficients are not opposite, but it's an easy fix. Let's go ahead and multiply the top equation by 2. Okay. So we take our time, multiply the top equation by 2, and that will leave you with 4x minus 2y plus 6z equals 14. Bottom equation was perfect. So let's go ahead, bring it down as is. So remember, we're trying to eliminate y. The biggest thing you can do is, the worst thing you can do to yourself is eliminate different variables from each pair. We want to eliminate the same variable from each pair. Coefficients are opposite, so we have green light to add the equations, and that will leave us with 5x plus 5z equals 14 minus 3 is 11. Sorry, it's a little late. It's like 5 o'clock in the morning. Alright, so let's go ahead, take our equations and join them to create our new system. Okay, so our new system is going to be given by 5x plus 5z equals 9, and then 5x plus 5z, almost the same, 11. Yeah, these don't look like 5s. Pretend you can read them. Okay. So we're going to focus on this new system, and we can solve it by substitution or elimination. With your permission, we're going to go ahead solve it by elimination because I love elimination. So this system has the variable x and z, so we need to find x and z before we even think about finding the variable y. Okay, so let's go ahead and do this. So which variable should we eliminate? It doesn't really matter. They're both 5, so I'm just gonna say let's go ahead eliminate x. So the least common multiple between the x coefficient is 5, so we want a positive 5 and a negative 5. We already have plenty of positive 5s. We want to get a negative 5, so I'm gonna multiply the bottom equation by negative 1. Cool. Okay, so the top equation is cool, and that will leave us with 5x plus 5z equals 9, and the bottom equation gives you negative 5x minus 5z equals negative 11. So fantastic. So let's go ahead verify that the coefficients on the desired variable are opposite, and when we do, we have the green light to add the equations, to eliminate the desired variable. So the x's cancel out, the z's cancel out, and that kind of makes me scared, and the sum of the constants will give us -2. So we were trying to find x and z and then find y, but that didn't happen. Okay, so when you're solving systems of equations, regardless if you have 2 variables or 3 variables, or you are solving by substitution or elimination, once the variables cancel out, that's it. There's no more math, like do this or do that. You have to stop, analyze your statement. Ask yourself, do I have a true or false statement? And I know that you know that 0 and -2 are not the same. So this is a false statement. So if the variables cancel out and we end up with the false statement, then that means that the system has no solution, which I kid you not, I'm really happy that we have a false statement, because when we have a true statement, we have a lot more work to show. Okay guys, so this was, I think, like the third video. I'll owe you 2 more problems, because this is a tough unit for me. So let's go ahead, do 2 more problems and call it a wrap. Thanks guys.